So we're going to talk about solving radical equations and rational exponent equations in this section. So solving equations, I always like doing that better because I get an answer at the end that I can take back and check in the problem, and it makes me at least feel a little bit more sure about my answers because I can plug them back in and see if that happens. And with the We'll start with radical equations that we don't convert to rational exponent equations first, and talk about how to solve those, and then we'll transition over into ones that have a rational exponent in the problem to deal with. So the key to solving both of these types of equations is to isolate the radical or the rational exponent. Portion of the as best possible. I mean, there are going to be we're going to see one or two here that there's more than one square root in or something like that. But for the most part, you're not going to see a whole lot of those. I'll show you one and how you can go about doing that. But the key to solving these things is just like when we did absolute value equations, the idea was to get the absolute value part by itself, and then you could set up your stuff to do that. Same thing happens here. Is you get the radical part by itself, and then you can get rid of the radical. Okay, just like we did, with the absolute value, we got it by itself. Then we could set up an equation or know what to do to set up the equations or inequalities with that. So it's the same idea with this. So we're just gonna instructions are gonna be solve. Be sure to check for extraneous solutions. And that's pretty important with radical and rational exponent equations, because there are those stipulations about taking the square root of a negative number and those things that we had to deal with the absolute value marks when we were simplifying. Those same things kind of can happen here with radical equations or rational exponent equations. We've got to be careful of those. So once we solve it, we may have multiple answers for some of these. We've got to check all of them to make sure that they work, and if they don't, they're an extraneous solution. We get rid of them to get there. So let's start with one that's fairly easy, not too difficult. So let's say we had the square root of x plus 7 is equal to 6. Fairly simple problem. The square root is already isolated. It's by itself. It's all that's on that side, and we got a number 6 on the other side. So we have the square root of something plus 7 is equal to 6, and we need to figure out what that something is. So what we want to do here is get rid of the square root. So the opposite of taking a square root would be doing what to both sides? Squaring it. Yeah, absolutely. If it was a cubed root, the opposite of the cubed root would be cubing it. That idea. So we're going to square both sides. What happens on the left side is this squared and the square root cancel each other out. And there we have our x plus 7 is all that's over there now. And then on the right-hand side, we got 6 squared. So we just say 6 times 6 is 36. And now we've got a really simple equation to solve. We just get x by itself. It's back to basics here. So we'll get rid of the 7 by subtraction. 36 minus 7 would be 29. I need to take that 29, even though I only got one solution, I need to make sure that it works in this problem. 29 plus 7 is 36. The square root of 36 is 6. The principal square root is what you're looking for there. Don't think about the plus and minus in there because you didn't put a square root in the problem. So whatever sign is in front of that square root, that's the one you're going to keep, you know, and use. So if it were a negative in front of that, you would think we take square root of 36 and say -6. So whatever the sign is in front of your radical, that's what's going to happen. So let's do one that's maybe a little bit more difficult. I don't know. Let's say we had the square root of x squared minus 3 plus 4 equal to, trying to get my numbers right here, I'm making these up here. Let's do plus 4 and then 10. All right, do that one. A little bit more difficult problem. The square root's not isolated here, so we've got to get that done first. So what do we move in order to isolate the square root? Yeah, just subtract the 4. And there we have it. Square root of x squared minus 3 is equal to 6. And then the square root is isolated. I can now get rid of it by doing what to both sides? Squaring. So it looks a lot like the other one. It's got the 6 over there and everything. Oops. And that's going to give us x squared minus 3 on the left side. And on the right side, we got 36. So we've got an x squared in the problem. Okay. The good news is that we don't have a plain x term. So that means I could use square roots to solve this problem. And that would be the quickest way to solve it. I could also get it equal to 0 and then try to factor it, or do a quadratic formula with it. I think I want to do square roots here because it's quicker. So I'm going to add 3 to both sides. And then we get x squared is equal to 39 out of there. And then to get rid of the squared, we're going to have to bring a square root into the problem. And because we're bringing the square root into the problem, we need a plus or minus in front of the square root of 39. Okay. Because we brought that square root into the problem. The others don't have a plus or minus because that was just the original problem. But when we bring a square root to the problem to solve it, we have to put the plus or minus in there. So we have two answers. We got the positive square root of 39, and we got the negative square root of 39. So we got two different answers to plug in and try. Okay, so we're going to plug in the positive square root of 39 in for x squared, and the negative square root of 39 in for x squared, and check those with that. So I'm going to use the calculator to help me do that. So I know I'm taking the square root of parentheses, the square root of 39, oops, square, come on, delete that parenthesis there. Try again. 39. Now, right, there we go. Squared. And then it was minus 3 on the inside of that square root. And then I pressed the right arrow key to get out of that. And then it said plus 4. So if this answer works, then I should get 10 after I hit enter. Hey, square root of 39 works. I'm going to take that same problem and I'm going to put in square root of negative square root of 39. So I need parentheses, negative square root of 39. 39. Right arrow key. Close the parentheses. Squared. Minus 3. Get out of there. Plus 4. If I get positive 10 here, then I'm going to keep both of those. If I get anything else, then I know to throw that one out. So that's what I'm trying to check here. Hey, I get positive 10 on that one too. So I'm going to keep both of those. as solutions to this. So I didn't have I had two answers. Turns out both of them work. And sometimes that happens. Sometimes you end up with one of them not working. Okay. So there's a good little problem. Let's say, go scroll down here and get example C. Let's say we had x minus the square root of 4x plus 12. And that's equal to 0. They'll do this to us and make it a little tough. They'll put an x that's not underneath the square root in that problem. And they'll say, okay, now solve that problem. So here, again, the first thing that you want to try to do is get the part that has either the square root or the rational exponent by itself. So on this one, you got two different things on this side, and they're not by, this obviously the square root's not by itself. It's got this x over here with it. This one could be done a couple of different ways. I think the easiest thing to do here is move this part because the x is already positive. And if I move this part that I've got circled, how do I move it? I would add that entire expression to both sides. And because it's a 0 over there, that makes it an easy addition to do. And that's going to get us x is equal to the square root of 4x plus 12. So the square root's on the right-hand side this time. It doesn't matter which side it's on, as long as it's by itself. Okay. And now we have, that same old problem. We got to get rid of the square root. So the way to do that is to square both sides. The same method. Nothing's changed. Square both sides. 4x plus 12 on the right side. X squared on the left side. So this one has an x squared in it, but it's also got a plain x term in there. So that means I can't do it by square roots. I've got to solve this one by getting it equal to what? I got to get it equal to 0 so that I can either do quadratic formula or factoring with this. It doesn't matter. I think this one will work either way with the numbers that are there. So I'm going to move the 4x by subtraction and the 12 by subtraction. Okay? And that'll cancel both of them out and get me x squared minus 4x minus 12 equals 0. So a little more room there. Oops. Can you do that? All right. Now, if you want to use the x method of factoring, it works on this one. If you want to do quadratic formula, it works on this one. I don't care which way you do it. There's nothing that says you can't do it one way or another. This one will do both. I'm a factoring person, but you may not be. You may rather do the quadratic formula. I'll work this one both ways just so we can review that because we've done that, but sometimes it's good to see it again. So I'm going to do it by factoring first, and then I'll do quadratic formula. So if I'm going to do it by factoring, I'll do the x thing. So 1 times negative 12 is negative 12, and then it's got to add to be negative 4. So that'd be negative 6 and positive 2. And the good thing about that, doing it by factoring, is there's a 1 in front of the x squared. So that means I can go straight to my factors, x minus 6 and x plus 2. And then set each of those equal to 0. And solve. So I get x equals 6, x equals negative 2. That's doing it by factoring. If I did it by quadratic formula, I would do 4 plus or minus, remember quadratic formula, x equals negative b plus or minus b squared minus 4ac. All right. That's our formula. A, B, and C are in order A, B, and C. So we're just going to plug those in. We got negative 4 squared minus 4 times 1, negative 12, all divided by 2 times 1. And I would use the calculator to help me do that part underneath the square root. So negative 4 squared minus 4 times A times C, and the square root of that, so plus or minus square root of 64 over 2. And I know the square root of 64, it's 8. And so I end up with two things to work out. 4 plus 8 over 2 and 4 minus 8 over 2. So that's 12 over 2. There's the 6 that I found with factoring. And then that's negative 4 over 2. And there's the negative 2 I found by factoring. Okay. So no matter which method I use to solve that, I'm getting the same two answers. Understand that not every one of them will factor. Sometimes you may have to do the quadratic formula because it won't factor. But it's easy to see that the factoring, if it does factor, is a little shorter, which is why I like doing it when it will. But either way, we get the same two answers, and we still got to check them in the original problem. So we've got to go back up to the original problem, x minus the square root, and I'm just rewriting it down here. 4x plus 12 is equal to 0. And I'm plugging in the 6 for x and working it out and seeing if I get 0. And I'm plugging in the negative 2 for x and working it out and seeing if I get 0 out of that. So we'll use a calculator to help me out here. So I got 6 minus the square root of 4 parentheses 6 plus 12. So I've just plugged in the 6 and I hit enter, and I hope I get 0. I do. 6 works. I'm going to keep it. It checks. I just put a check mark by it so I know I've already checked that one. And then I'm going to put a negative 2 in that place. So negative 2 minus the square root of 4 parentheses negative 2, close the parentheses, plus 12. And then see if I get 0 when I do that one. I got negative 4, which is not 0. So what's that mean about the negative 2? It's an extra answer that doesn't work. We throw that out. But the negative 2 is thrown out. So 6, x equals 6 is the only solution to that problem. We have an extraneous solution of the negative 2. Just mark it out in both spots there. So anytime, especially when you get more than one answer, you definitely want to check them. I check them even when I get just one answer, because there are times when a problem may have no solutions. And the only way to catch that is to check the answers that you do get out of that. All right. Let's look at one that's got a cubed root in the problem. See how we do with that. The cubed root of 5x squared minus 12x plus 6 is equal to the cubed root of x. All right. So cubed root on both sides of that. So this is one of those where it's got more than one of the root things in it, remember the rule was you had to isolate the root. Well, there's two of them to isolate here. Are they each isolated? One on one side, one on the other? Yeah. And if that happens, that makes this problem a lot easier if that can happen. And we'll see one in just a minute where it can't happen, and I'll show you what that looks like. But here, because you got a cubed root, everything on this side's underneath the cubed root. Everything on this side's underneath the cubed root. So if I were to cube both sides to get rid of it on this side, guess what it does on the other side? It gets rid of it too. So it works really wonderfully to help us with this problem. It gives us 5x squared minus 12x plus 6 is equal to x. And because it has the x squared in it and some plain x stuff in it, that tells me I need to get it equal to what? Got to get it equal to 0 to solve it. So anytime I got an exponent on my variable and then some other pieces that have that same variable on it, I know I got to get it equal to 0. So the best way to do that is just subtract this x and get rid of it. That's one step. And that gets us 5x squared minus 13x plus 6. And again, it's a quadratic, so that gives me two options for solving this. I can either solve it by factoring or I can solve it by quadratic formula. You're going to get the same answers either way. So I don't care which way you do it. I'm going to do factoring because I already know the numbers. And I was thinking about 5 times 6 is 30. And it's got to multiply to be 30 and add to be negative 13. So that'd be negative 10 and negative 3. So, anytime I see the numbers and I kind of know what they are, that's when I like to do factoring instead of quadratic formula. Just because I think it's quicker. Maybe it's just because I'm better at it. Or I don't have to, square things and multiply a whole bunch of stuff together. I just got to do a little bit. So I'm going to group be 5x, be x minus 2, be a negative 3, be x minus 2. So my factors are then x minus 2, 5x minus 3. I'm going to get two answers here, and I've got to check them to see what's up. So I'm going to solve those. X minus 2 equals 0. That's the easy one. It's x equals 2. The other one, going to get a fraction in it. I'd add 3. 5x equals 3 divided by 5. And we get this fraction, 3/5. Okay. And again, I got to go back to the original and plug this in and see if they work out one at a time. So I'm gonna plug in the 2 and see what it gets me when I do the left side, and then do it in the right side out of that. So I'm gonna check those. Original problem. So I'm doing a cubed root. So I'm gonna hit math, and then I got that cubed root button that I can use. And it's 5 parentheses 2, close the parentheses, squared, minus 12 parentheses 2, and then plus 6. So I get that. It's a decimal, but that's what I got. And then on the other side of the equation was the cube root of x. Well, so I'm going to do the cube root of 2. So math, cube root, math, cube root of 2. Hey, it's the same decimal. So that means the 2 works for sure. All right, so I'm going to check by that. I know it worked. All right, so then I got to plug in the 3/5, which it's already a fraction, so I know I'm probably going to get a decimal back out of that, but that's okay. I'm just checking to see if it's the same decimal on each side. So I'm going to go back and I'm going to do the cube root of 5 parentheses 3/5 squared minus 12 parentheses 3/5 plus 6, and get that 0.84 and some change out of that. And then I'm going to just go to the other side of the equation and do the cube root of that 3/5. See if it's the same decimal. It is exactly the same decimal. So that means that works as well. So I'm going to keep both of those. I don't have an extra solution on that. So don't always think, hey, I'm going to keep one and throw out the other. There's no set rule that says you always have one answer when there are two, or you've got to really just check them all. That's the only way to verify that that's going on. All right. So let's look at one that maybe is not quite as easy, that has multiple square roots in it, and we've got to deal with getting rid of them. And so this one, you'll need probably a whole piece of paper for this one. A whole front side of a piece of paper for this one at least, or front or back side of it. All right, so let's say we got the square root of 3x plus 1 minus the square root of x plus 4 equals 1. All right, so it's not equal to 0. So that's what makes this one a little different. I don't even know what letter I'm on. E. Okay, because this is not a 0 on the right-hand side, this one is different than the one we've already done that had two square roots in it. So again, the main focus when you're trying to solve any of these radical functions or the ones with the rational exponent is get that part that has the radical or the rational exponent by itself first. Well, there's two parts that have that. And so my goal here is just try to get one of them by itself and then deal with the other one later. Okay. So I think the easiest thing to do would be get this 3x plus 1 one by itself, because all I got to do is just add this to the other side. It's similar to the way I did the previous problem that we had done with that. So if I add the square root of x plus 4 to both sides, that gets me the square root of 3x plus 1 equal to, and I'm going to write this with the square root part in the front and then the plus 1 in the back. Because I think it makes it, to me, it makes it easier to have the square root in the front when you go to do the next step. Okay, because the next step would be, okay, we isolated one of the square roots, so I'm going to square that to get rid of it, right? So that's what we've done every time, is we took the whatever root it was and did the opposite of that. So here we're going to take and square both sides, and this is where the right hand side's where the hard work is. The left hand side's the easy stuff, and I'll do that part. I'm gonna let you guys do the right hand. I'm just kidding. I'll help you with the right hand side. The left hand side though is by squaring that, we got that 3x plus 1 by itself. It doesn't have the square root anymore, so it makes it a little bit easier. Okay, and then the right hand side though, it's squaring the square root of x plus 4 plus 1. So that, what does it mean to square something? It means multiply it times itself, right? So if I square this stuff, that means I'm going to write two of them. Now, if it were a number over there, we'd just write the number twice and multiply it together. But because it's this polynomial stuff, we got to multiply these things together. So this is going to go back to, okay, well, now we got to multiply square roots together that are, so we got to deal with that. So let's deal with it. So it's just distributed property twice. So the left-hand side is going to stay the same. So I'm just going to go ahead and copy it down so I feel like I'm done with something. And then I'm going to multiply the square root of x plus 4 times the square root of x plus 4. What happens if you multiply, just think about this as a side thing here. What's square root of 7 times square root of 7? And it might even be better to think about it on the calculator. If I multiplied the square root of 7 times the square root of 7, I get whatever was underneath the radical, right? I do the same thing if I did the square root of 114 times the square root of 114, right? I'd get whatever was underneath there to begin with. So when I multiply, so what I'm doing is trying to show you that this is actually not that hard to multiply these two together, because it's the same thing underneath both of them. The square root's just going to go away, and it's going to leave you x plus 4 when you multiply those two together. That makes that a lot easier. And then I got to do another distributive here. So I'm distributing the square root of x plus 4 to the 1. Oh, well, what's 1 times anything? It's the same thing back, right? So that's going to be plus the square root of x plus 4. Technically, there's a 1 there. Maybe that'll help us later. We'll put it there. So I've distributed this square root of x plus 4. Now I've got to distribute this 1 to both of those. So 1 times the square root of x plus 4 is another 1 square root of x plus 4. And then 1 times 1, that's an easy one. I got that. 1, right? Now I look at that right-hand side, and I've got some like terms that I can put together, right? So I've got, pick a color here. I got the 4 and the 1 that can go together. So that's going to give me x plus 5. But look at these two guys. they're both square root of x plus 4s. And they have a 1 in front of them. So that means it's 1 square root of x plus 4 plus 1 square root of x plus 4. So that means there are how many square roots of x plus 4? There's 2 of them. That still looks a little tough, but here's the good news. This stuff here has like terms over on the other side, right? So I can move those over there. And if I think about, if I just pretend, hey, I haven't done all of this work above that line, and this is the problem they gave me to begin with, what's my job? It's get the square root by itself, right? So I'm just working to get this other square root of x plus 4 by itself. So I'm going to move the x and I'm going to move the 5 to the other side. And then I got that 2 in the front, but maybe I can figure out what to do with it. Let's get these over there. So move the x and move the 5. That's going to give me 2x minus 4 is equal to 2 parentheses, or 2 and then square root of x plus 4. Okay, so, all right. There's a 2 in the front of the square root. So the square root's not technically by itself yet. How can I get rid of that 2? Yeah, because it's multiplying over here. I could divide by 2 and get rid of it. So if I divide this side by 2, I got to divide everybody on the left-hand side by 2 as well. And it works out pretty nice on this one. It's kind of like I meant for it to happen. 2 divided by 2 is 1x, or just x. And 4 divided by 2 is 2. So I get x minus 2 is equal to the square root of x plus 4. And finally, I now have a problem that has the square root by itself on that right-hand side. And how do I get rid of that square root? I square both sides again. We're still not done. Okay. Now, when I square both sides, the right-hand side is the easy side. It's x plus 4. But on the left-hand side, I'm squaring x minus 2. So that means x minus 2 times x minus 2. And so we gotta do that math. We gotta distribute the x. X squared minus 2x. Another minus 2x. And then a plus 4. And then I'm going to simplify that. That's x squared minus 4x plus 4 is equal to x plus 4. And because it has an x squared in it, what do I need to do? Get it equal to 0. That's right. Get it equal to 0. Anytime you got an x squared and some plain x pieces, you got to think, I got to get it equal to 0. Okay, so I'm going to move this x by subtraction. I'm going to move this 4 by subtraction, which works out nice to make this easier at the end. X squared minus 5x. Because those all cancel out. This 4 and that 4 cancel out. So that all I've got left is x squared minus 5x. Okay, equal to 0. From there, I can factor that by using a greatest common factor. What's the greatest common factor of x squared and 5x? X. I could also do quadratic formula with a being 1, b is -5, and c is 0. Since there's not a plain number there, you could do quadratic formula. You're going to get the same 2 answers. But the GCF factoring there is too easy to not do it that way. So we set up x equals 0. So there's an answer. X minus 5 equals 0. There's another answer. So x is 5 or 0. But I got to check them. I don't even remember what the original problem was. I'm going to go back and write it down. The original problem was 3x plus 1 underneath the square root minus x plus 4 underneath the square root is equal to 1. That's what I'm checking those in. Okay. So I'm going to go and I'm going to use the calculator to help me check them. So square root of 3 times 0 plus 1 minus the square root of 0 plus 4. And then I got -1. Is that what was on the other side? No, it was +1. So it looks, it's close, but it's not the same. So that tells me that's an extra solution. I'm going to throw it away. I wonder if 5 is extra too. I got to check it. I hope it ain't, because I did a lot of work to get it. So I'm going to plug it in. So 3 parentheses 5 plus 1 minus, oops, square root of 5 plus 4. So that's going to be 16. Square root of that's 4 minus 3. It is 1. It works. Yay. I didn't waste my time. So 5 works, 0 doesn't. So we get one of the answers that we found is answer. Those are the toughest ones because they take the most amount of time. You won't see more than one of those. You may not even, I haven't seen one like that on a final yet. That's that long. Most of the ones, if they do have that, something is a 0 and it cancels out real quick, and it's much shorter. But I like to show one of those just to show you, hey, you can do it. It just takes one piece at a time. It's like any of this other stuff. It's always the same. Now, I'll show you the easier problems. The ones with the square roots and the radicals in it, to me, are the harder problems. The ones that I think are the easiest are the ones with the rational exponents, because there's easy ways to get rid of those nice things, and they don't do the polynomial thing to you with the rational exponents, because you usually have a numerator on your fraction, so they're a little nicer to you with these. So I'm going to show you those. So letter F here. We'll start with something pretty easy. X to the 3/2 is equal to 216. Really simple one-stepper. Okay, now here's the trick. Make sure the part with the rational exponent is isolated. In this case, it is. Once you get that done, you want to use a reciprocal exponent. Reciprocal means what? For a fraction, what's the reciprocal? Flip it over. That's what a reciprocal does. So the reciprocal for 3/2 would be 2/3. So I'm going to raise both sides to that 2/3 exponent. This is the same idea as squaring to get rid of a square root. Because remember, a square root is the same thing, a square root of x is the same thing as x to the 1/2 power. And the reciprocal of 1/2 would be 2/1. So it's the same idea. It's exactly the same math operation. It just looks a little different because it's a fraction. And then on the left-hand side, because we use the reciprocal, they cancel each other out. And there's x. And then on the right-hand side, I get 216 to the 2/3 power. And I can try that on the calculator and see if it works. And if it does, great. If it doesn't, then I know I got to do the factor tree thing. Okay, so I'm going to try it with the calculator. 216 raised to the 2/3 power. Okay. And it is 36. It works out nice on this one. That's nice. Let's take one that's maybe a little bit more to it, but not much. Example G. Let's put x plus 7 inside of the parentheses, and then raise that to the 2/5 power. And let's put it equal to 4. Now, is the part that has the rational exponent by itself? Yeah, it is. So that I can get rid of that rational exponent by using the reciprocal power. which would be 5 over 2. We just flip that fraction. 2/5, the reciprocal is 5 over 2. The beautiful part is that these cancel each other out. And that leaves me x plus 7 on that side. On the right-hand side, this is where, I made a big deal back when we were talking about simplifying these problems, that if you had an even index, what you had to put in there. Well, that's an even index. It's a 2 in the denominator. What did we have to put in there if there's a 2 in the denominator? When it was a variable, it was absolute value. When it was a number, it needs to be plus or minus, because we're going to work that out. We're going to work out that number, 4 to the 5 over 2 power. We need to get a positive and a negative out of that because the denominator is even. On example F, the denominator was odd, so we didn't have to worry about that. On example G, the denominator is even, so that's why we have to worry about it. So plus or minus on that. So we're going to work that out. 4 to the 5 over 2 power. 4 raised to the 5 over 2. Plus or minus 32. Okay? So that means we've got two equations to solve here. We've got x plus 7 is equal to positive 32. X plus 7 is equal to negative 32. And we're just going to work that out. Subtract 7, 25. Subtract 7, negative 39. Okay. And again, I'm going to go back and I'm going to check those in the original problem to see if they work. So 25, it's 25 plus 7 raised to the 2/5. And I should be getting 4, and I do. On the other one, it was negative 39 plus 7 raised to the 2/5. And I get positive. I'm going to keep both of those. So we, even though it's a rational exponent, it's not a radical anymore, we still need to go back and check those and make sure that they are correct solutions to that. So both of those are going to check on that one, and we need, we're good on that. All right. So let's do another one here. Say we had parentheses 2x minus 4 to the 3/7 power, and that's equal to put that equal to negative 2. All right, so we have an expression that's got a rational exponent on it, and it's equal to negative 2, but the rational exponent part's by itself. And that's, again, key to starting any of these problems. Make sure that's happening. And it is on this one. A lot of these are already set up and ready for you in this particular section. So how do we get rid of the 3/7 power? We use the reciprocal power, which is 7/3. Okay. That's going to give us 2x minus 4 is equal to negative 2 to the 7/3 power. I don't know what that is. I'm going to work that out. Negative, need parentheses on that. Negative 2 raised to the 7 over 3. It may not be a good number. It's not. And that's okay. I want that to, it's okay if that happens. So that's negative 2 to the 7/3. We're going to leave it like that. Okay? And we're still going to be able to solve this for x. We're just going to have that weird looking number in our answer. Okay? So how do we get x by itself for this problem? Yeah, you're just going to add 4 to both sides, and that's going to give us 2x is equal to negative 2 to the 7/3 plus 4. and then one more step. Divide everybody by 2. And so that's going to give us x equals -2 to the 7/3 over 2. 7 looks weird, so fix it. And then 4 divided by 2 ends up being 2. And I find that answer. Why did I not put a plus and minus in front of that at the blue step there? What wasn't even? The index, the denominator of the fraction that I put into put on that side, the denominator was not even. That's why I didn't put a plus or minus. If it is even, you have to put a plus or minus. Okay? And then you would have 2 problems to work. So this is a decimal answer, and I'm going to use the calculator to check it in the original. So I'm gonna work that out. -2 raised to the 7/3, and then divide that by 2 plus 2. I'm gonna get that decimal, and I'm gonna use that in my checking of this. So I'm gonna plug in that decimal without rounding it at all to the 2x minus 4. So I'm gonna say that answer times 2 minus 4, and then that raised to the 3/7. The original was 3/7. Yeah, that raised to the 3/7. And I got -2 back, which is what the other side had on it at the beginning. So that checks out of that. Even though it was that ugly answer like this line up here that got me the -0.519 stuff, it still can be checked. You just get the decimal, but don't round it when you plug it back in. Don't try to type it into your calculator. Let the calculator use the answer thing to work that, because then it stores actually it stores the infinite decimal of that keeps going forever. It stores this actual statement here instead of that decimal. It doesn't round it ever. If you type it in, it's going to round it at some point. So you've got to be careful about that. So checking those is paramount in doing these kinds of problems. So we got rational exponents, we got radicals that we've dealt with. We've dealt with equations that deal with these sort of things. So we've done quite a bit of stuff there, and that allows us to get ready to go into logarithms and things next week, which is it's related to exponents. Logarithms are exponents, but they allow us to work with really, really large numbers or really, really small numbers with those based on the exponent rules. So this weekend, I'll send the videos to you and what labs and what quizzes to do, and we'll go from there. R6, these problems out of your textbook. R7, these problems, just the odds. Obviously, you get that. You can check answers on odds, and then on the 1-6, these types of problems. And we'll meet Tuesday, 4 o'clock, and then Thursday we're off next week. So I'll see you on Tuesday, and we'll keep going. All right. You guys have a great weekend.
I have a question.
Yes, ma'am.
On the